Now we're going to be looking at a different type of division called synthetic division. Now we can only use this if we're dividing by x minus a or x plus a, something really, really simple. So let's say we're dividing by x minus 3. For synthetic division, we set it up a little bit differently. So we make a box. It's kind of like an upside down division. On the outside, I'm dividing by x minus 3, but I'm going to take the solution to x minus 3 equals 0. In other words, what's the 0 of x minus 3? Well, that's going to be a positive 3. Across the top, I'm going to be putting my coefficients. So this is the coefficients from what we're dividing by. So the coefficient of the first is 1, 4, negative 5, and 5. For synthetic division, the process is going to be, we're going to bring down the first term. A different color, olive green. Bring down the first term. So that's a 1. Now, we're going to multiply like we did in long division. So 1 times 3 is 3. But the difference here with synthetic is we are going to add down. So 4 plus 3 is 7. 7 times 3 is 21. Add down. Get 16. 16 times 3 is 48. And we're going to add down. So that's 53. What I end up with is going to be 1 less degree than what I started with. So I started with an x cubed. I divided by an x, so I'm going to have 1x squared plus 7x plus 16. What's left is the remainder. Let's do another one. So we're going to divide 5x cubed plus 6x plus 8 by x plus 2. I'm going to make my box. X plus 2. So if I take x plus 2 equals 0, I get a negative 2. Now I have to put my coefficients across the top. 5x cubed. Oh, the next one should be x squared, but I'm missing x squared. Six x plus 8. Bring down the first term. Multiply. Add down. Multiply. Add down. Multiply, negative 52, add down. Synthetic division goes really, really, really fast. So that's the nice thing about it. Is once you get the rhythm, it's really not bad. So this is 5x squared because it's going to be 1 degree less, minus 10x plus 26. This is my remainder over what I divided by. I invite you to try this next one. Pause the video, try it, and then when you think you got it, press play. Hopefully you got the same thing. Now, there's something really interesting that I want to share, and it's called the remainder theorem. There's something super special about this remainder. So, let's take that same function, x cubed minus 4x squared plus 5x plus 3, and let's say I wanted to find f of 2. In other words, plug 2 in for all the x's. I'd get 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. Takes a long time, right? 8 minus 16 plus 10 plus 3. I end up with 5. F of 2 is 5. F of 2 is 5. So if I wanted to find out, if I plugged in a certain number here, what the output is, I can use synthetic division to also evaluate functions. So let's say we had, this would be example 4, f of x equals I am making this problem up, so if it is ugly, I so apologize. Squared 3x plus 1. Okay, and I wanted to find f of negative 2. Okay, so I always get messed up on the negatives. I end up forgetting to put parentheses around them. It ends up becoming ugly. So what we can do is write down our coefficients across. 3x to the 5th. There's no x to the 4th. Hold on. Oh, they sound like they're going to make an announcement. Minus 4, 2x squared, negative 3x, and 1. This remainder is going to be super important. On the outside, I'm putting negative 2. That's what I'm plugging in. Bring down. Negative 6. Add. Multiply. Add. Multiply. Ooh, I almost messed that one up. I'd messed this one up and nobody caught me. Negative 6 times negative 2 is 12. That's going to be an 8. I've really messed that up. That's a negative 16, negative 14, 28, 25, negative 50, and I get a negative 49. This is telling me that f of negative 2 is negative 49. add another example in here. Okay, how would I know if something is a factor? So here are my choices. If something is a factor, if I divide, I would have 0 as a remainder. So what we're going to do is take each one of these and divide into that function. So x plus 5 means I'm going to put a negative 5 right here. 1x to the 4th minus 5x cubed, no x squareds, 20x, and a negative 16. One times negative 5 is negative 5. Add is negative 10. 50, 50. Do you think I'm going to get, oh, this is getting even bigger. I don't see how this one's gonna work. So this one is not. Let's try the next one. So x minus 4 means I'm going to put a 4 on the outside. 1, negative 5, 0, 20, negative 16. 1 times 4 is 4, negative 1, negative 4, negative 16. Whoops, I forgot to put my remainder box. 4, 16, 0. So this one does work. That means it is a factor. That means I can multiply x minus 4 times, this would be 1 less, so this would be x cubed minus x squared minus 4x plus 4. Now, I checked x minus 4. I did not check x plus 2. Now, the beautiful thing is, sort of like when you were dividing numbers, if I've already divided out one of the factors, I can divide what's left. This is called repeated division. Now I can take x plus 2 and divide that into what's left after I factored out the x minus 4. So what's left is 1, negative 1, negative 4, 4. And if I'm dividing by x plus 2, I'm going to put a negative 2 on the outside. And lo and behold, it's a factor too. So that means my original function could be written as x minus 4, because that was the first one I divided evenly by. Then I divided by x plus 2, and now I have x squared minus 3x plus 2, which factors. So we have a technique now that we can factor something all the way down quite easily.